Okay, so the first question that we are going to solve is two sum. So let's read the question. Given an array of integer nums and an integer target, return indices of two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Okay, so what all we've been given, the first thing that we know is that one solution exists. The second thing that we know is that we can't use element at same index twice. Okay, so let's start it. So the first thing that I will be doing is that is brute force. Now what brute force is? So for this example, let's see. When I'll be at 2, so initially what I'll be doing is I'll have two loops, one ith loop and another would be a nested loop. So when I'll be at 2, I'll be checking for 7, 11 and 15. I'll be adding 2 plus 7, 2 plus 11, 2 plus 15 and checking whether they are equal to 9. Then I'll be doing the same for 7. I'll be adding 7 and 11, 7 and 15 and meanwhile I'll be checking whether they are equal to 9 and then the same for 11. So let's do it. I'll simply be saying this is my ith loop and this is my j loop. Okay, so the reason that I'm going for I plus 1 is that because I've been said that we cannot use the same index twice, right? And then I'll be saying if nums of I plus nums of j equal target, then I'll return new integer. Then I'll return the indices. Else I'll be returning null. Let's compile it. Okay, it's running. Yes, okay. The problem with this though is that it is way too slow, right? You can see that it has taken 51 milliseconds. Now we need to think of a faster approach, right? So yeah, in this scenario, we have been told to return the indices, right? We've been told to return indices, right? So the thing is that if we change order, we'll have to store the indices of the elements in another array and later on we'll have to map them, right? Which would take lots of time. So a better approach would be to directly use a map to store the elements, right? So what I'll be doing is I'll be taking a map integer and integer. Okay, so I'll be store this map will store the values and their index. Okay, what I will be doing is I will store all the values. I'll store all the values in one loop, and in other loop I'll check whether there is any value such that its complement exists. So by complement, what do I mean? So here we have been told that there are two numbers, right? A and B is equals to target, right? So so I can say that B is equals to target minus A, right? So let's say if I store all the values, let's say 2, 7, 11 and 15, right? So when I'll be at 2, I'll be checking whether in the map 9 minus 2 exists. If it exists, that means that there are two such values that add up to my target, right? So I'll simply be storing these values to my map. Nums of I, that is the value to index, right? Now in another loop, what I'll be doing is I'll be checking if the complement exists. I'll say complement is equals to target minus nums of I, right? This is what we decided in here, right? A plus B equals to target. So let's say B is equals to target minus A. This is what we decided, right? Okay, so Now I have found my complement. Now I'll check whether this complement exists in my map, right? Map dot contains key, and I'll say complement. Okay, and if it contains, I'll simply be returning the indexes, and if it does not, then I'll simply return null. But here is the catch, here is the catch, wait for it. I'll be saying I, and the other value would be map.get comp complement, right? So now the problem would be that let's say there is a test case where I have been given values such as 1, 2 and 3, and my target is 2, right? Then this solution would take 2 times 1, right? And this solution would say that there is that 1 and 1 can, sorry, 0 and 0, value at index 0 and value at index 0 can add up to 2. But we have been given a restriction that we cannot use element at same index twice. So we'll also give a condition that if this occurs, and, right, and we'll say that map dot get complement is not equals to I, right? I've said that the index of this value and this value are totally different. Let's try to run it. Okay, it's running. Okay, yes. Now, okay, we can see that the runtime has increased drastically, right? So, can we optimize it any further? Okay, so let us look at the question, right? Yeah. So now we need to think that what we were doing initially was in one loop, in first loop, we were storing all the values, storing all values. And in second loop, we were checking if complement exists. Complement to current value exists, right? Uh, it, but what if in this first loop only, uh, what let's say I have two, or let's take a better example. Okay, let's say 3, 2, 4 and 7, right? And the target is my 11 is target. Okay, so let's say in the first, when I'll be at 3, since the complement of 3, that is 11 minus 3, is not in here, so right, I'll be ignoring 3. Then I'll be at 4, then I'll see that 11 minus 4 does not exist in my map, right? Then I'll be ignoring my 4. Ignoring, by ignoring means put it in map, put it in map, right? Then when I'll be at 7, I'll see that 11 minus 7, that is the complement of 7, that is 4, exists in my map. So here I'll return my answer that 4 and 7 exists. Okay, so let's try to implement this. So what I'll be doing is I'll be using a loop. Now what I'll be doing is I'll check if map dot contains key, and contains key what, the complement, right? I'll even have to calculate the complement, that is target minus nums of I. Okay, so if my complement exists, right, if my complement exists, that means simply return new integer array with I and the complement, that is map.get comp. Okay, if it does not exist, we'll put this value in map so that for the later go we can check this particular value. So I'll say nums of I to I, since we are mapping from value to index. Okay, so let's try to run this. Okay, it's working. So we can see that from 5 milliseconds it has come to 3 milliseconds, right? So yeah, this is the solution. Thank you.